Good evening to all. Let me introduce myself. I am Nandini from SRAT College from CSE department. I am really happy today to be here. I strongly believe learning is more important when I share something. So I glad this opportunity. Thank you. Let's move on to the topic. Today my subject is chemistry. In this subject I want to explain and share something that is principles and applications of NMR and IR spectroscopy. Let's move on to the topic. Introduction. Spectroscopy is the study of interaction of matter with electromagnetic radiation. NMR. NMR means nuclear magnetic resonance. In IR means infrared spectroscopy. NMR and IR are more important analytical techniques used to determine molecular structure, identify function groups, provides information about molecular framework. So this is the introduction of NMR and IR spectroscopies. Next. What is IR spectroscopy? IR spectroscopy is an analytical technique that uses infrared light to identify chemical substances by measuring how they absorb or emit IR radiations. Principles of IR spectroscopy. Principles of operation. IR spectroscopy principles have four. They are molecular vibrations, absorption, functional groups, dipole moment, requirements. Molecules absorb infrared radiation and undergoes vibrational transitions. Absorption depends on both strength and atomic masses. IR reasons 4000 to 400 centimeters to the power of minus 1. Products IR spectrum with peaks of functional groups. It is used to study and identify chemical substances or functional groups in solids, liquids, or gaseous forms. This is the principles of IR spectroscopy. And molecules are made up of atoms linked by chemical bonds. The movement of atoms and the chemical bonds like spring and balls vibrations. This diagram represents vibration of a diatomic molecule approximates an oscillating spring. These characteristic vibrations are called natural frequency vibrations. These are the principles of IR spectroscopy. These are the instrumentation of IR spectroscopy. IR source, reference, monochromatic system, sample, splitter, detector, reabout. So these are the instrumentations of IR spectroscopy. Next, applications of IR spectroscopy. Identification of functional groups, detection of impurities, study of polymer degradation, analysis of organic and inorganic compounds, forensic and atmosphere. These are the applications of IR spectroscopy. These are the known as what is IR spectroscopy and principles and applications. Next, what is NMR? Nuclear magnetic resonance spectroscopy, most commonly known as NMR only. Spectroscopy or magnetic resonance spectroscopy is known as MRS, is a spectroscopic technique to observe innate local magnetic fields around atomic nuclei. It is a spectroscopy of technique that is based on the absorption of electromagnetic radiation in the radio frequency region nuclei of the atoms. Over the past 50 years, NMR has become the preeminent technique for determining the structure of organic compounds. Of all the spectroscopic methods, it is the only one for which a complete analysis and interpretation of the entire spectrum is normally expected. This is known as what is NMR, that is natural resonance spectroscopy. These are the structure of the nuclear magnetic resonance. Magnetic controller, magnetic field, printer, absorption detector, RF transmitter, sample tube. These are the main parts of the nuclear magnetic resonance spectroscopy. Next, an NMR spectroscopy mission or spectrometer is a device that uses a strong magnetic field and radio waves to analyze the structure of molecule at an atomic level is known as NMR spectroscopy, and these are the diagram of the NMR spectroscopy. Next, principles of NMR spectroscopy. Principles of operation same. There are four principles. They are nuclear spin, external magnetic field, resonance and detection, chemical environment. Nuclei with spin behave like tiny magnets. In a magnetic field, they absorb radio frequency radiations. Chemical shift shows electronic environment. Splitting pattern gives information about neighboring atoms. These are the principles of the NMR spectroscopy. Next, applications of NMR spectroscopy. Structural evaluation of organic compounds, determination of purity, identification of isomers, study reaction mechanisms, forms the basis for medical diagnostic imaging, that is MRI, and applications in the food and oil industries. Nowadays all are using these food and oil industries also. Next, comparison between IR and NMR. IR means infrared spectroscopy, NMR natural magnetic resonance spectroscopy. It is a functional group identifications, but in NMR it is a detailed structure analysis. IR uses infrared radiations, NMR uses radio waves. It is in vibrational transitions. NMR is in nuclear spin transitions. IR is the result of absorption of light by vibrating molecules. NMR is due to the scattering of light by vibrating molecules. These are the comparison between NMR and IR. Next, conclusion of IR and NMR. IR and NMR are powerful tools. IR and NMR are powerful tools in chemical analysis. Nowadays, they are more coming powerful tools. IR reveals functional groups only. NMR provides structural details. Together, they form a complete molecular characterization method. These are the conclusion of the IR and NMR. Thank you.